Okay, so today we are going to be proving similar triangles. So let's look at the first question. What is the difference between similar triangles and congruent triangles? So think about that for a minute. From what we learned about similar triangles and what we've learned about congruent triangles, what do you think the difference is? Well, in similar triangles, corresponding sides are in proportion, whereas in congruent triangles, corresponding sides are congruent. So that's really the main difference between similar triangles and congruent triangles. So we know that two triangles are similar if there's two things going on. Think about those two facts that we've already talked about with similar triangles. Corresponding sides are in proportion, and corresponding angles are equal. Okay, so we're going to do our first proof, proving similar triangles, which would be example number 1. Now, if we take a look, it says, prove triangle ABC is similar to triangle DEC. Now, when we did triangle congruency proofs, we had many different postulates to choose from. We had side, 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 angle, side, hypotenuse, leg. We had all different postulates that we can prove congruent triangles. The good thing about proving similar triangles is there is only one way to prove similar triangles, and that's going to be using angle. So let's take a look at what we're going to do. First things first, we look at our givens, and it tells me that AD and AB are perpendicular, and it tells me that AD and ED are similar. Perpendicular. So, you know what, since I'm proving these two triangles are similar, I'm just going to highlight them like we do normally with congruency proofs. I'm going to write my givens, which are AD is perpendicular to AB, and that's given. And we have AD is perpendicular to ED, and that's also given. All right, so we know what perpendicular means. And we know that when we see perpendicular, there's going to be two statement reasons I'm going to need that go together. So since we have here and here, we know that angle 1 and angle 2 are right angles. And the reason is perpendicular lines form right angles. And then, if you remember, we would say angle 1 is congruent to angle 2 since all right angles are congruent. Okay, so we have one pair of corresponding angles congruent to each other, angle 1 and angle 2. Now, we used all of our givens, so same thing like when we proved congruent triangles, we would look at the two things that we can assume. The two things we can always assume, if you remember, are vertical angles and reflexive. Now here I do have a bow tie, and we know that bow ties form intersecting lines which have vertical angles. So angle 3 would be congruent to angle 4 because intersecting lines form congruent vertical angles. So now we can stop there because now we have two sets of corresponding angles that are congruent to each other. So therefore we have similar triangles. So we have triangle ABC similar to triangle DEC, and that would be because of angle. Now, it's important to know when we are proving similar triangles, we're only dealing with angles. We're never dealing with any kind of sides. Angles only is where we're going to focus. So, I'm going to have you, let's see. I'm going to do example number 2 and example number 3 with you. And then I'll have you try some on your own and we'll go through it. So let's take a look at example number 2. Example number 2, they want me to prove that BAF would be right here, is similar to triangle BCE. So again, I'm going to highlight my triangles so this way I can see what I'm working with. So let me write down my givens. I have angle A congruent to angle C. And remember, you always want to mark your givens. So angle A is congruent to angle C. I have BE perpendicular to DC and BF perpendicular to AD. And that's given as well. Now, we do have our perpendicular. So I have BE perpendicular to DC. So here's my right angle. I can call it angle 1. And I have BF, which is this right here, perpendicular to AD, which would be right here. So here is my angle 2. So I have angle 1 and angle 2 are right angles. And that's because perpendicular lines form right angles. I have angle 1 congruent to angle 2. So remember, those always go together because all right angles are congruent. So now I have to ask myself, do I have angle? Yes, I do. I have two pairs of corresponding angles that I proved equal to each other, so therefore I have similar triangles. Triangle BAF is similar to triangle BCE, and that is because angle. Now, we didn't actually need box number 6, so we could even just cross that out. And there you have it. And last one, example number 3. Now, if you feel that you have a good handle on this already and you want to pause this video and try it on your own, you're more than welcome to do that. That's the beauty of having a video. So let's take a look at what we have here. So they want me to prove triangle ABC is similar to DEC. Here we have my other triangle. So first, let's write down our given. We don't really have a lot of them, so let's just look at it. So we have that AB is parallel to DE, so that's given. All right, so we're given parallel lines, so I just want to point this out to you. So if I have parallel line, which is AB, and DE, don't I have parallel lines cut by a transversal? So I would have a transversal there. I also would have a transversal right here. Now, if you remember your properties or your special angles that are formed with parallel lines cut by a transversal, you would be able to see that angle 1 and angle 2 are corresponding angles. Because remember, if I was to draw a box, angle 1 would be in the bottom left, and angle 2 would be in the bottom left. So they would be in the same spot. So therefore, they're corresponding angles. You would also realize, if you remembered parallel lines cut by a transversal, that angle 3 would be congruent to angle 4, because again, they're in the same spot. So you would have your angle. So I have angle 1. Now you can only have corresponding angles when you have parallel. So make sure you have those parallel lines given. If you don't have parallel lines given, you cannot state that you have corresponding angles. So parallel lines cut by a transversal form congruent for corresponding angles. So we could really end there. We have our angle, and we can move on. But I just want to show you something else. What if you only saw one pair of corresponding angles? And you would say, okay, what do I do now? Well, we can always look for a reflexive. Now, I'm just going to erase this so we can get a better idea of what's going on here and what I'm talking about. Okay, so if I was to highlight this again, so if I have ABC, and then I have DEC, DEC, you will notice that both have angle C in the triangle. If we look, angle C is in both triangles. So we would call that the reflexive property. So that should really be review. Now we didn't have to put that for this particular one because we already mentioned our angle, which we had angle 1, angle 2, angle 3, angle 4. But you might have only noticed 1 and 2, or you might have only noticed 3 and 4, and you needed that extra angle. So that's how we can get it. So therefore, I did prove triangle ABC is similar to triangle DEC, and that's because angle. All right, so what I want you to do right now is I want you to pause this video, and I want you to try, let's see, give number 1 a shot and see if you can do it. So go ahead, hit pause. I want you to try number 1. When you hit play, we'll go through it. So go ahead. Okay, so now that you tried it, let's see what you did. So we have to prove that triangle ABC is similar to triangle DEC. All right, so let's see here. So I'm given that DE is parallel to AB, and that's given. So remember, parallel lines cut by a transversal. So here's my parallel lines cut by a transversal. So we have corresponding angles. So I can call this angle 1 and angle 2 and have corresponding angles. Now you could have also saw the other transversal. So let me point that out to you if you didn't see it. So if you look at your other transversal, that's also going this way. So I have my parallel lines cut by my blue transversal. So again, we would have angle 3 and angle 4 because again, they are in the same spot. So we have angle 1 congruent to angle 2, angle 3 congruent to angle 4, and that is because parallel lines cut by a transversal form congruent corresponding angles. Now, you can end there because we do have our angle, right? We have two sets of congruent corresponding angles. But some of you might have went a different way with this. Some of you might have said the reflexive as well. If you notice, again, C is in both triangles. So, since C is in both triangles, I'm going to redraw both triangles so you can see what I'm talking about. So if I had ABC and CDE, hold on, that's not correct. So it's A, B, C this way, D, C, E. Both of them have C in there, so therefore we would have reflexive. So if you went that way, that is also 100% correct. Reflexive. So we did prove that angle ABC is similar to angle DEC, and that again is by angle. And that is how we prove similar triangles.